What are we going to do today? We're going to be able to take the implicit derivative of the equation of a non-function curve. And we'll talk about what that means in a second. How are we going to do this? We're going to take the derivative with respect to other variables and leave a factor of dy dx behind to account for our chain rule. And the reason why we're going to do this is a really powerful tool because up until now, we've only been able to take the derivative of like a function. And now what we can do is we can take the derivative of any equation, whether it's a function or not, no matter how the variables are set up. So let's go ahead and look at these two equations. Now, this first one, we can take this and just rewrite it and make it look all nice and right? We can make it look like that, and then we can take the derivative and find the slope of the function. And that's easy, right? The derivative, this part goes away. The derivative of x is 1, so we're left with negative 2/3 for our derivative. Here, we don't have that option. We don't have the ability to solve for y. This is unsolvable for y. Or at least it's unsolvable for y in a way that we're never going to do. This is uh, a cubic equation, and there is a formula to make a cubic equation, but it's not. We're not going to do that ever. Period. It would take so much longer than what we're about to do. So before I show you how to do it on the ugly one, let me show you how to do it on the one that is simpler. So what we're going to do is we are going to take the derivative with respect to x of the entire equation. That means every single thing here is going to get a derivative. The derivative with respect to x of 2x is 2. The derivative with respect to y, anytime we have a derivative that's not x, whenever we're going to treat it like normal, but then afterwards we're going to put a dy dx on it, times to it. So the derivative of 3y, we would normally expect it to be 3. The variable goes down a exponent and then goes away. But since it's not the variable that we normally are expecting, we're going to have 3 times dy over dx. Basically, we're going to, this y gets snatched up and put right here. Yeah. And then we take the derivative of 5, and the derivative of a number is always 0. And now if we want to find what the derivative is, we got to solve for dy dx, right? So subtract the 2 over and divide both sides by 3. And that's the exact same thing that we had when we did it the normal way, when we rewrote it as y equals negative 2/3 x plus 5. We took the derivative and dy dx was negative 2/3 there as well. So I hope that sort of helps you to see that it works. For a situation like this up here, you may or may not want to use this tool. You may or may not say to yourself, well, that's too much. I don't need to take the implicit derivative. I can just do this. Yeah, and that's fine. Nobody's going to tell you one way or the other. But that's not why we have this tool, right? We don't have this tool for something like this. I mean, we can use it, take the derivative, take the derivative, take the derivative, and then solve for dy dx. And you may like that way. And you may choose to use that all the time in weird situations. But the reason we have problems like this is because of something like this. Like we can't solve for y. So what I'm going to do now is I'm going to show you how to do this one. So look, we're going to do the exact same thing we did before, but the one thing to keep in mind is that we have two different functions here, right? 2x and y are multiplied together, 3x squared and y are multiplied together. So we are going to have to use the product rule. All right. So we're going to do this first one, left d right plus right d left. So we got 2x times 3y squared dy dx. Remember, anytime you take the derivative of the not x, you got to put a dy dx after it. Plus right d left, 2 times y cubed. Notice I didn't put a dy dx here because I was doing the derivative of the x this time, right? And now we're going to do the other one. Left d right plus right d left. 3x squared times derivative of y is 1 dy dx. Plus right d left. 6x times y equals the derivative of 5 is still 0. So that part didn't change, right? So now look at what we have. We have, and there's a plus sign in here, my apologies. What we have here is, let's make everything neater. We got 6xy squared dy dx plus 2y cubed plus 3x squared dy over dx plus 6xy. And now all I'm going to do is I'm going to take all the ones that don't have a dy dx and move them over to the other side. And then I get 6xy squared dy dx plus 3x squared dy dx equals, and I subtracted both of these over. And now I'm going to pull out the dy dx and divide by whatever's left, right? So I'm going to divide by 6xy squared plus 3x squared over to the other side and leave myself with this dy over dx. So this is in the numerator. This is in the denominator. And what I've done is I have found my derivative. And the application portions of problems like this, you're going to be given a point somewhere on this ridiculous looking curve. And you're going to be asked to find the slope, or you're going to be asked to find where there's a tangent line or a normal line. And I think we've talked about normal lines before, but we will go back and review what that means when we go through some of the problems that ask for them. But so at this point, we're going to be getting real deep here. So let's do a bunch of problems. I've got a bunch of them, and we're going to get through as many as we can so that you have models for how to do your homework and how to do the quiz, okay? So look at the directions. It says use implicit differentiation to find dy dx. So it's basically telling us, hey, do what you just did. So let's take the derivative of all three of these. The derivative with respect to x. So the derivative of x to the fourth is 4x cubed. The derivative of y to the fourth, we're going to do the same thing. 4y cubed, but since we're taking the derivative of y, there's going to be dy dx equals 12xy. So we've got a 12x and a y, and we're going to do left d right plus right d left. Left d right, so we've got 12x times the derivative of y, which is just dy dx, plus right d left, 12, the derivative of 12x is 12, and then y. So let me rewrite everything to make it look all nice and pretty. We've got 4x cubed plus 4y cubed dy dx equals 12x dy dx plus 12y. So once again, I'm going to get all the dy dx terms on the left, and I'm going to get all the non-dy dx terms on the right. So the 4x cubed is going to get subtracted over here. The 12x dy dx is going to get subtracted over here. So what we'll have is all the dy dx is on the left, minus this one over here, equals, and then we're going to do the 12y, and then we're going to subtract the 4x cubed. So now we've got the dy dx's on the left, we've got everything else on the right. We're going to divide away everything to get the dy dx by itself. So we've got 12y minus 4x cubed over 4y cubed minus 12x. And as far as I'm concerned, and as far as the AP test is concerned, you don't have to do this. But if you notice, there's a factor of 4 everywhere in here. So what you could do is you could divide a 4 out of everything in the top and everything in the bottom, and you could simplify it down to make it look nicer. 3y minus x cubed over y cubed minus 3x y cubed. That's a terrible looking y. I'm gonna fix that. It doesn't look very good. But so the point is, like, if you're told to take the implicit derivative, that's it. You know, the 3 steps. Take the derivative of each piece, like I did here. Maybe clean it up a little bit if it helps. You could actually, from this first step, divide 4 out of everything, but you don't have to. It's going to be the same amount of work to divide it out up here as it is up here if you're going to do it. But step 1, take the derivative, right? Step 2, get the dy dx on the left. And step 3, divide it out, get dy dx by itself. And if you could do that, you can do anything. I'm telling you. Like, same thing, right? We're about to do another one. Same thing. Now here, it's going to depend on how you feel about it. You can either use chain rule on the left here, or you could FOIL it out. Either way, it's totally up to you. It'll give you the same answer, right? So I'll do it with chain rule first. I'll do it both ways just so y'all can see it. So chain rule, we're going to take the derivative of the outside. Times the derivative of the inside. Equals the derivative of this, which is 12 dy dx. So I think maybe the pitfall here is all this silliness. Yeah. This is going to be a pain in the butt to do this way, isn't it? I wouldn't do it this way. I would get here and say, this is hot garbage. Don't do it this way. Just because then you would have to FOIL this anyway. And so if you're going to have to FOIL, you might as well do it while it's easy. So and that way you don't have parentheses to deal with after you take the derivative. So we're going to take the derivative here. Not yet. We're going to FOIL it first. 3xy times 3xy. 3xy times 4 plus 3xy times 4. Then 4 times 4. See, I'm telling you, 9 times out of 10, if you do the algebra first, it'll make your life so much easier. Look at this. Because now, look, yeah, you have to do product rule a couple times, but it's going to be so much easier. Left d right plus right d left. So we got 18xy squared plus 18x squared y, because that, it's just take the derivative of the x squared, bring it down, take the derivative of the y squared, bring it down, and when you take the derivative of the y squared, make sure you do dy dx. Plus, again, left d right plus right d left, and if it helps, you can break it up into the x term and the y term. Left d right plus right d left, so we got 24 y plus 24 x dy dx. And the derivative of 16 is 0, so we can just ignore that one. Derivative of 12y is 12 dy dx. And now get all the dy dx's on the left, get everything else on the right. Or if you want to do it the other way, you can do that too, but I like dy dx on the left, everything else on the right. That's my way. So we got this one, and this one, right? Also, this one, and this one. They have the dy dx, move them over to the left. This one and this one do not, so we'll move them over to the right. So we got 18x squared y plus 24x minus 12 equals, and then these other two on the other side, negative 18xy squared minus 24y. And they're negative because we moved them over to the other side, right? So just be aware for y. And then it's 4. And then divide all these over to the other side. We've got dy over dx equals negative 18xy squared minus 24y all over these three. 18xy squared. Oh, my bad. Squared y, right? Plus 24x minus 12. And then once again, if you notice, I think there's for sure a factor of 6 that I could pull out and just divide everything by 6, just to make it nice and neat. Six, right? 4x minus 2. Yep. Okay. So I'm gonna tell you, one like this, don't do chain rule. Especially, you've got stuff trapped in there. It's gonna make it difficult to try and solve for dy dx. If you've got something that can be FOILed out so that it's just a nice long line of easy polynomials, do it. Make it easy on yourself. Don't make it hard on yourself. Make it easy on yourself. All right, let's do the next one. We got 4y squared equals 3x minus 2 over 3x plus 2. So once again, we have something that we can do implicit differentiation for. So we're going to take the derivative of both sides with respect to x. So this gives us 8y dy dx equals, and then we're going to do the quotient rule, low d high minus high d low over low squared. So low d high, I just put the 3 out front because it looks easier, minus high d low over low squared. And then for those of you who are weird about, putting stuff into and around fractions, remember if you want to divide this 8y away, which is what we want to do to get it over here, you can just take this and just dump it into the denominator on the other side. That's allowed. That's what we're doing anyway, right? We're dividing by 8y, so just put it in the denominator. So squared. And the bottom here isn't going to change. Just leave it because there's probably not going to be much to do. And even if there is something to do, it's not going to happen by foiling this out. We can simplify this and it might help us get something. So let's see, we got 9x plus 6 minus 9x plus 6. So 9x minus 9x is 0. 6 plus 6 is 12. That did make it easier, and then we can actually take the 8 and the 12 and simplify that, right? 12 and 8, we can divide these two numbers by 4 each, and we get 3, 2y, 3x plus 2, the quantity squared. That is an awful 2. Let me try that again. There we go, much better. So this, again, all we're trying to do is find the slope function, right? This is our equation. This is the slope at any place x and y. That's all it is. Don't think too hard about these. They're not difficult. They're not difficult. Take the derivative of each piece separately so that you're not working too hard. I promise you it's a lot easier if you take the derivative of each piece separately. All right, next one. Same thing, right? Take the derivative of both sides. What's the derivative of x? Isn't that just 1? What's the derivative of sine? Isn't that cosine? And then cosine of y dy dx. And now we're going to solve for dy dx, and we just need to divide the cosine over to the other side. So this is dy dx equals 1 over cosine of y. And if you're feeling particularly, frisky about it, you can rewrite this as secant of y. So if you've got x equals the sine of y, you take the derivative with respect to x, and you end up with the secant of y. That's what it is. All right. See, very simple things. Also, very simple. Just take the derivative of each piece. Take the derivative with respect to x of each piece. I think the derivative of cotangent is negative cosecant cotangent. I'm just going to really quick double check because as y'all remember, I avoid memorizing these things because memorization does not equal learning. Sure, we'll go with this one. The derivative of cotangent is negative cosecant squared. Okay, see, this is why I always double check. Derivative of cotangent is negative cosecant squared. All right, so we take the derivative of each piece. Derivative of x, 1. Derivative of cotangent, negative. So we'll subsume this plus sign with a minus sign, right? Negative cosecant squared of xy. So now we have to use the chain rule, take the derivative of xy times 1y, because I took the derivative of x, and now I'm going to take the derivative of the other side, plus x dy dx equals, well, derivative of -4, which is 0. So you're going to see this happen a lot too, where one side's just going to completely be gone. And so you put that 0 there, and then you can basically solve for the dy dx slowly, right? Because you can subtract 1. You've got negative cosecant squared of xy times y plus x dy dx equals -1. And if you like, at this point, you can say, hey, a negative on one side, a negative on the other. Save yourself some time and energy going forward. And then you just divide the cosecant squared, leaving us with, y's are really wild today. Sorry, folks. This right? And you can actually rewrite that as sine squared, if you like. But then you're going to subtract the y and divide by x, yeah? I'm going to rewrite this as sine because I like that better. I'm going to subtract y. Sine squared xy minus y. We're going to divide both sides by x. And that's it. I've finally solved for dy dx, right? But it's the same principle each time. Step 1, take the derivative of every piece. Step 2, solve for dy dx. In this case, there's not a lot of time to get all the dy dx's on one side, but they're already on one side. So now it's just getting everything else rid of, right? And that's what we have. All right. So let's look at the next one. Same thing. We're going to take the derivative of both sides. So left d right plus right d left. Derivative of sine is cosine. Derivative of the inside. And again, I'm just taking the derivative of y, and when I do that, that's dy dx, right? Left d right plus right d left. That's just the derivative of x is 1, so I'm just left with this sine of 2x plus 7y. What is that equal to? Y times the cosine of x. Well, let me do a lefty right plus righty left again, right? So derivative of cosine is negative sine. Plus derivative of y is dy dx. So let's pretty this up. Let's make it look better. Yeah, let's make this look better. So I'm gonna distribute this into this to free up our dy dx, because we have to do it for this one, unfortunately. In the last one, it was a pain in the butt to get that and do stuff with it, but here we actually have to take this part, distribute it in, right? So we got, I'm going to start over here, give myself some room. 2x cosine of 2x plus 7. Let me not make that. Times, that's we times to the 2, now we're going to plus, and we're going to do the same thing times the 7 dy dx, right? 7x cosine 2x plus 7y dy over dx plus the sine one equals, and then this one we don't need to do much prettying, just negative y sine x plus dy over dx cosine x. Oh, this is so long. Okay. So again, highlight your stuff so that you know what goes where. No dy dx, no dy dx, no dy dx. And then the one over here, this has a dy dx. This one has a dy over dx. Okay, so we'll get the blue ones on the left and the red ones on the right, and then we'll make it look nicer. Okay, so we got 7x cosine of 2x plus 7y dy over dx minus, I'm going to subtract this over to the other side, cosine x times dy dx equals, we're going to subtract these two over, and this one's already negative, so they're all going to be negative. Cosine 2x plus 7y minus 7x cosine of 2. Oh, wait. Sorry, minus. Copying the wrong thing. I want to copy the red ones. Minus sine of 2x plus 7y minus y sine x. Okay. Hey. Now, divide all these things that aren't dy dx over. So our final answer after all that is this divided by these two, right? All over these 7x cosine 2x plus 7y minus cosine x. Phew. I'm going to try and reassure you that if there is more to do, they won't be this raunchy. Like here, all they're telling you to do is find dy over dx. And so they're going to make those a little bit worse because this is the only thing you're doing. But as you go through and you see some of the problems that are more application based, they're not going to give you anything as ugly as the ones that we've done so far. But this is to help you build the skills. Like if you don't know product rule, if you don't know quotient rule, you're going to have a rough time. So make sure that you're good with those. Make sure that you ask for help on those if you're still feeling like you're struggling. Okay? All right, once again, here we're finding dy over dx, but now they changed the variables. So now y is r and x is theta. If it helps you, I mean, you could really literally just, over here, hey, y is r and x is theta, and then change it to be x to the negative 5/6 minus y to the negative 5/6 equals 9. And you could do that and then just remember to put the variables back when you're done because they don't want x's and y's, they want r's and thetas. But if you're cool with this, just you can go ahead and do it. If you're not cool, you can rewrite it out and just change the symbols to be more familiar. I'm going to do it here. So for both of these, remember that you're just using the power rule. So bring down the negative 5 over 6, theta, and then to the subtract 1. So negative 5 6 minus 6 sixths is negative 11 sixths. And then you could bring that down here. So the two negatives are going to cancel, leaving us with a plus 5 over 6 r to the negative 11 over 6. And then this is our implicit one. This is our y. So this is times dy dx or times dr d theta equals, what's the derivative of 9? 0. Derivative of any number is just by itself is always 0. So now I'm just trying to solve for dr d theta, right? So I'm gonna add this over and then divide, right? So I add over 5 sixths r to the 11 over 6 dr d theta equals, don't forget your negative signs up here. Those don't change, right? And also, if you notice that you got a 5 6 here and a 5 6 here, you can cancel those out, right? Don't make your life hell. Make your life easy. Then I'm gonna divide by r to the negative 11 over 6, leaving us with theta to the negative 11 over 6 over r to the negative 11 over 6. And okay, so AP test, leave it like this. No one is going to say a word to you. This is correct. This is dr over d theta. But if you've got negative exponents like we have here, and everything's just divided like this, you can just take the reciprocal and get rid of the negatives, right? R to the 11 over 6 over theta to the 11 over 6, right? You can bring this up to the numerator, this down to the denominator, especially since, there's no plus signs or minus signs. Like it's not like theta plus 1, right? It's not r to the whatever plus 5. So since it's all here, you can just flip them and that's fine. You don't have to. By no means do you have to, but if it helps you to think about it this way, and so you can. I'm not saying you have to. Alrighty, continuing on. So now, see how this is a lot easier this time? Now we're going to find dy over dx and the second derivative. So, first one, we've got, take the derivative, 8x plus, take the derivative, 2y dy over dx equals derivative of 1 is 0. Subtract the 8x, divide the 2y. And you can rewrite this, and you're going to want to rewrite this as this. So here's our dy over dx. That's step 1, check. Now we got to do d squared y over dx squared. So we're taking the derivative again of this piece, right? Well, quotient rule, right? Low d high minus high d low over low squared. Low d high, so minus high d low. And then remember the derivative of y is dy dx over low squared. And so look at what we have. Look at what we have. We have our second derivative Our second derivative is this. How do we deal with the fact that this is dy over dx? Well, don't we know what dy over dx is? Isn't that negative 4x over y? So I can just take this, replace it with this. So look at what I have. I have negative 4y minus 16x squared over y squared. And once again, like, you're allowed to leave it like this. But if I multiply everything through by y to take care of this fraction in a fraction, it'll look a little bit less ugly. I just multiplied this by y, multiply this by y, multiply this by y, with the intent of clearing out this fraction, right? So I'm not telling you that this answer is incorrect, but I am telling you that this answer is pretty. And again, on the AP exam, stop here. Make your AP grader earn their paycheck. Who knows? Going down the line, it could be me doing that grading. And you're going to want that to be me. You're going to want to see me sit there and sweat for a while. So look at this one. Here, they're not even asking you about dy over dx. They're just telling you go straight in d squared y over dx squared, right? Now, here's what I'm going to tell you. You go through, you find your dy over dx. Same as you would, I want to say it's negative x squared over y squared. Obviously, I'm going to show you why, but and then you take the derivative again, you get that, and then you're going to plug in 3 for x and 3 for y. But let's hold on to this. So let's do this out. Take the derivative of each piece, 3x squared plus 3y squared dy over dx equals 54's derivative is 0. Subtract the 3x squared, divide by 3y squared. And that is, in fact, once you simplify, negative x squared over y squared. So now, once again, take the time to take the derivative again, so you get d squared y over dx squared. Low d high minus high d low over low squared. And here's what I'm going to tell you. Yeah, you could take this and put it right here, but we're trying to get a numerical value anyway, right? You don't need to. You can plug in 3 for x and 3 for y everywhere. You can actually get the derivative here, and then you can plug the number in here. So you don't have to. You can find out that 3 squared is 9, 3 squared is 9, so this is going to end up being, at the point 3 comma 3, this is going to be negative 1, right? So this is going to be negative 1, right? And you just plug in 3 everywhere you see an x and everywhere you see a y, right? So we got negative 2 times 3 times 3 times 3. This is like negative 54, right? 3 squared is 9 times 3 is 27 times 2 is 54. Plus this one, 9 times 6, 54 times a negative 1. So minus 54 again over 3 to the fourth power, 3, 9, 27, 81. And then like just simplify. This is negative 108 over 81. And there's totally a 9 in the top and the bottom here. I think that's 9 times 12, right? 9 times 10 is 90 plus, yeah. Okay, so this is 9 times 12. So we're going to end up with negative 12 over 9. And you can still simplify this to negative 4 over 3. But again, like according to my AP summer camp that I took, you leave it here. The value of d squared y over dx squared at the point 33 is, you leave it here on the AP test, you get the right answer. Math Excel is going to want this. But like you leave it here on the AP test because why wouldn't you? Heck, you could leave it here. You could leave it here. I will show you the most ignorant way you could leave it and still get full points. If you leave it here, you still get full points. You leave it here, you get full points. So don't do too much. On the AP exam, you leave it like this, you get the points. Don't make life difficult for yourself. Make life difficult for the grader. So you get everything done that you need to get done. So we've seen this before. Find the slope of the curve. So we want to find m at 1, 1. Well, here's my x1 is 1. Here's my y1 is 1. So let's find the slope. Plug in so that we can get the number, and then we don't even need, we're not even going to make an equation. We don't have to find the tangent line. All we need to find is the slope. So all we need is m. So let's find it and plug it in. And again, don't do too much here. So we got, take the derivative of each of these, 28y cubed dy dx plus 35x to the 6th equals derivative here, 3 dy dx plus derivative of 9x is 9. And okay, could you go through and do it the exact same way we've done it beforehand, then plug in all the numbers, then simplify? You could. Would that be a gigantic pain in the butt? Probably. Is there an easier way? Definitely. Especially since these are both 1. Plug in 1 for the variables, right? 1 cubed is 1. 1 to the 6th power is still 1. So at the point 1 comma 1, look, now it's 28 dy over dx plus 35 equals 3 dy over dx plus 9. Isn't that feels simpler, doesn't it? To me, it does. Now you can subtract it over. I have 28 sheep. I'm going to subtract 3 sheep. So now I have 25 sheep. I'm going to subtract the 35 over, and I get 9 minus 35, negative 26, I think. Yeah. Then divide that over. There's the slope. Do we need these anymore? No. Are we making a line? Are we trying to find the equation of a line? No, we're just finding the slope. We're just trying to find out what m is, what dy dx is. Same thing here. Given points on a curve, here it says find the lines that are tangent and normal. So, tangent line, normal slope, right? X, y. And then the normal line is the one that's perpendicular. So whatever the slope is here, opposite reciprocal here, but still the same x and y. Right? Perpendicular. Figure that out. Get our x, get our y. Our x is 4. Our y is 5. Do this first. Get all this out the way. So all you have to do is find what m is, and then opposite reciprocal to find what this is, and then you can make your lines. So derivative, 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 derivative. Right? Derivative of x squared is 2x. Derivative of xy, left d right plus right d left. X dy dx plus y times 1. Minus derivative of y squared is 2y dy dx equals derivative of 11 is 0. So, and again, at this point, do I care what x and y are? I've got them, so why don't I just plug them in? Make my life easier. So, at the 0.45, I know, well, 2 times 4 is 8 plus 4, x is 4, so plus y, well, y is 5, minus 2y minus 10, dy dx equals 0. And then again, just, simplify and solve for dy dx. It's all on the same side. I'm going to simplify it while it's here. 8 plus 5 is 13. 4 minus 10 is negative 6. Combined all my like terms. I'm going to add the 6 over. And I'm showing you all these extra steps. If you do some of this in your brain, nobody's going to kill you. So there's our tangent line. There's our slope of our tangent line. Our normal line, opposite reciprocal. So all you're going to do is flip the fraction and change the sign. It was 13 over 6. Now it's 6 over 13. It was positive. Now it's negative. Ta-da. Now you know how to do this. Y minus y1 equals m times x minus x1. That's this one. This is part A. And now you're going to do the exact same thing for part B, but now with this slope instead of this slope. Otherwise, it's the exact same thing, right? So again, if you front load all the work, then you can take the derivative real easy, get it done, and then go back to algebra 1 land and do that thing. Pretty simple. Let's see. I want to make sure that I use the rest of our time wisely. So like here, they're having you fill in some blanks here. And it's just saying, how do you know that this point, -1, -2, is on this curve? Well, we know the points on the curve because when -1 substituted in for x and what? -2 is substituted in for y. The resulting statement is, what's -1 squared? That's 1. What's -2 squared? That's 4. 1 plus 4 equals 5. 5 equals 5, which is a true statement, right? That's how we know that this point is on this curve. and then it says, then find the tangent and normal lines. Literally the exact same problem. I believe in you. Find 2 points where the curve crosses the x-axis. Well, where does the curve cross the x-axis? Isn't that at y equals 0? That's where we cross the x-axis. So all you got to do here is say, all right, well, x squared plus, and then y is 0. So this is literally just x squared equals 79. So the two x values are plus or minus the square root of 79. Now that you've done that, the second part of this is saying, what is the common slope of these tangents, right? So this is right here, this is part A. For both of these, y is 0. So you got radical 79 comma 0 and negative radical 79 comma 0. Those are your two answers. Make sure to type them as ordered pairs and use a comma to separate the answers. So like this. Right? And then once you've done that, that's part one. Part two, take the derivative, find the slope at radical 79. It's going to come out nicer than you think it will. It should come out okay. I think all the radicals cancel out. But you do it and just plug it in, radical 79 for x, 0 for y once you take the derivative, and everything will come out very nicely. What is the slope at these 2 points? Well, all you're going to do is you're going to take the derivative, plug in x and y, and find what the slope is, dy dx, right? Same thing we've done over and over and over again. At what point other than the origin does the equation have a horizontal tangent? All right, so you do this. What this is asking is, for part B, horizontal tangent means the derivative equals 0. So you're going to find what the derivative function is. You're going to set that equal to 0. Now, I'm assuming that this is going to be kind of a fraction-y type thing. Set the numerator equal to 0, because the denominator is not going to get you the horizontal tangent line. But for part C, find the coordinates of the point other than the origin where the equation has a vertical tangent. That's where, for dy dx, the denominator equals 0. And then here, at that point, all you're going to do, solve for x and y, right? Solve for x and y and get that final answer. So again, this is talking about line that's normal to the curve, intersects the curve at what other point? So basically, here's what you're going to do. You're going to find that normal line just like we did back here. Just like we did back here. Find what it is. Y minus y1 equals m times x minus x1. It says that it intersects the curve at 6, 6, but it's also intersected somewhere else. So what you can do is you can solve for y, plug it in, and get that answer. So like, let's see. What's the last one? Is it that? Yes, it is. We'll get to that. That one's easy too. 2x plus 4x dy dx plus 4y minus 10y dy dx equals 0. I'm going to move these over. 2x plus 4y. This comes out to be over 10y minus 4x. We plug in 6 for both x and y. 12 plus 24 equals 36. 60 minus 24 equals 36. So the slope is 1. So this is the slope. We want the normal slope. It helps to write it as 1 over 1, right? Flip the numerator to the denominator, change the sign. -1, right? The opposite reciprocal of 1 is -1. Y minus y1 equals m times x minus x1. Oh, that's nice. So this is going to be y equals, I'm going to write this in slope-intercept form because it's going to make my life easier. -x plus 12. And all you have to do is plug it into the original equation for y. So we got x squared plus 4x times minus 5 times squared. And then, do your thing here. We've got x squared minus 4x squared plus 48x minus, this is x squared minus 24x plus 144. So minus x squared plus 24x minus 144 equals 0, right? Because it equals 0 up here, equals 0 up here. Combine all your like terms. -4x squared plus 60x minus 144. And I can divide everything by -4 to make it easier. One of these answers should be 6, 6, right? Because that's the whole point. X squared minus 15x plus 36. I just divide each of these by -4. So we got x minus 12, x minus 3. So we get these two possibilities for x. And what we need to do is just see what the y value is here. Plug in 3 for x, plug in 12 for x 2 separate times. One of them is going to come out bad. One of them maybe you do the quadratic formula and it comes out with a negative underneath the square root. Here, let's see. So we got 9, 12y, 5y squared. Let me rewrite this out. I just moved everything over to the other side and flipped the 0. B squared minus 4AC. 144 minus 180. Minus 4AC, so plus 180. This one's going to come out and it's going to give you something. 324 is a perfect square, right? This comes out nice. Yeah, it's 18 squared. Yeah. So like, okay, so this one comes out nice. So we know it's going to be this one. Since it says at what other point, the other one is going to come out as a imaginary number. We don't want that. So negative b all over 2a. This is 18. So 12 plus 18. 12 minus 18. And so if I plug in the 0.33, I check the point. This is the y value, right? This is the x value, 3. If I plug that in, I get 0 equals 0. So I know that one works. If I were to try 3 negative 3/5, I don't think that works. Yeah, it can't. 3. I think there's multiple answers here, which is nice. You could pick the easy one and move on with your life. What else? This one. I included this one just because it says something complicated. So it's something very easy, very complicatedly. The graph is called a blah, 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 blah. This is called a semi-cubal parabola. We want to know what the constant b is so that this meets the graph orthogonally. Don't think too hard about this. Find the normal line that's the orthogonal, what the orthogonally is telling you. This says find the normal line. Determine the constant b. Well, what is this so that you get the normal line? So let's do it out. Right? Divide it over. So what we want to know is, here's my here's my thing here. The slope, look, they tell you the slope. It's negative 1/3, right? So now you know. So now you're going to know what you're going to be able to find out this point because you're going to have two equations, right? Cross multiply. And then the other one. So now let's solve for y. Just get that over here. And then we're going to put that in where y goes. So we've got subtract that over. Can factor out x cubed. So here, x is either equal to 0 or, but then I plug in x equals 0 and I don't get the negative 1/3 here, so that doesn't work. Or x equals, if I solve for x here, 4/9. And if I were to do that, I would get 1/3, right? And I plug in y. So x equals 4/9. Let's find y in the original, right? Y squared equals 4 cubed over 9 cubed. Oh boy. 4, this is 64. 9, 81. 729. And then y squared equals this. So square root, and you get 8/27. This is my y value. And all I'm going to do from here, y minus y1 equals m. That tells, we know that already, times x minus x1. So what we can do is we can distribute and solve for our y equals. Distribute this, we get negative 1/3 x plus 4/27 plus 8/27 plus 12/27, which you could simplify to 4/9, right? If you go through, that should be b, your y-intercept. Final answer there.